Okay, so far we have our original DNA strand that we were looking at and our first example of a mutation. And so in this example, which is different than what you're doing, we saw that a G had been placed instead of a T, which changed our mRNA strand. So this is actually called a substitution because we're substituting one base for the next. But when we looked that up in the codon chart, we saw that it was the exact same amino acid that it coded for, and it didn't change anything else. So we said that for the example, like today's lab, we would say there was no change. In our next example, we have a change here. So here's our original at the top. And the change is a T that was substituted where there should have been a C. So again, notice we have a substitution. So instead of a G, we'll have an A here. And so when we look up AGA, so here's AGA, notice we're going to get arginine as our amino acid. And initially, it wasn't arginine, it was glycine. So we have a change. That change is going to be what we call a substitution. So if this were our activity, our lab activity that we're doing today, you would circle substitution. And this time, notice that we're going to have a bigger change. All the amino acids, well, we'll have one amino acid change, not all of the amino acids, because notice all the rest are the same. So it's going to be a substitution and then one amino acid changed as a result of that. So let's look at another example. In our next example, we have another change, another substitution. Again, where there should have been a G, there's an A that was substituted. And so that changes our mRNA code and codon. And so when we look up UAA, notice that we get a stop codon that makes the protein completely stop being formed. And it's kind of like stopping a sentence halfway through your thought. So again, we will have a substitution. So we'll circle that. And the result of that will be a premature stop signal. So this example here makes the protein not functional again. In the next example, we're going to add a whole letter in that's going to shift everything down to the right. So notice that here's our original DNA strand, and a G is being added between this G and this T. So that's going to push everything down one, and it's going to mess up all of our three, reading the codons three at a time. And notice we have this extra base left over. So if you notice this when you're doing yours, and obviously you'll see that all of the amino acids changed as a result, this is called a frame shift mutation. And we would say that all of the amino acids changed after that point of mutation. Notice that this frame shift was actually a result of an insertion of a letter. Sometimes a frame shift can also be a result of a letter being deleted, and so all of them get moved up one. So those are pretty much all of your options that you may have on today's activity, and hopefully this will help you become more familiar with not only how to look up codons in the codon table, but also what to do if there's a mutation.